Hello everyone, welcome to SPEC eLearn, the online learning channel dedicated to chemical engineers. Selection of pumps for high viscosity liquids, centrifugal pump or screw pump. In this video course, you will learn how changes in viscosity affects the pump performance, efficiency of centrifugal pump versus screw pump at higher viscosity, and why screw is better at changing viscosity. Life cycle cost of centrifugal versus screw pumps. Typical applications of twin screw pumps. Please subscribe to the channel. By subscribing, you will motivate us to produce more knowledgeable video content for you. So subscribe now before you forget. Both centrifugal pumps and screw pumps are widely used in refineries and petrochemical plants for transporting varieties of liquids, but they belong to different technology groups. Centrifugal pumps belong to dynamic pump technology and twin screw pumps belong to rotary positive displacement pump technology. Centrifugal pumps are default choice for many industrial fluid transport applications. The reason being, the liquid handled in many chemical process industries are of low viscosity. The technology is well proven, reliable, efficient, and does not suffer from many maintenance problems. The customer finds comfort with it, and it is not easy to convince a user to switch to alternate pump technology. When it comes to selecting a pump technology for handling high viscosity liquids such as those used in refineries and polymer industries, the process engineer needs to go beyond his comfort zone and take serious view of some of the factors of centrifugal pump working. Centrifugal pumps are typically designed to work within plus or minus 10% of best efficiency point BEP. What is best efficiency point? Best efficiency point BEP is a measure of optimum energy conversion. While selecting centrifugal pumps for a given application, the pump efficiency or design should be taken into consideration. It represents a unit of measure describing the change of centrifugal force expressed as the velocity of the fluid into pressure energy. The BEP is the area on the curve where the change of velocity energy into pressure energy at a given capacity is optimum. That is to say, the point where the pump is most efficient. This figure shows the centrifugal pump characteristic curves at different impeller diameters. For example, consider the pump curve at a 200 mm diameter impeller. The curve in red color corresponds to 200 mm dia. Observe the BEP point in green color star. Operating the pumps far away from the BEP and transient operating conditions has detrimental impact on the pumps. This emphasizes the importance of making proper pump specification and selection. Failures of many critical parts of the pumps such as bearings, seals, etc. can be traced to the pump operation at points relatively far away from the BEP point. The overall reliability of the pump goes down when operated outside the recommended operating limits. That is what happens when the viscosity of the pumped liquid changes. Centrifugal pump performance gets negatively impacted when handling high viscosity applications, particularly when the viscosity increases away from the design specifications. Twin screw pumps can be considered as reliable and efficient alternative to centrifugal pumps in many critical services. As with other physical properties, viscosity of the liquids, such as polymers and crude oil, are affected by temperature. As the temperature decreases, the viscosity increases. For most oils, the viscosity varies significantly as a logarithm of the temperature. So the ability of the pump to handle the oil gets impacted. This figure shows the effective viscosity on twin screw pump performance compared to centrifugal pump. The system curve 1 corresponds to viscosity of the fluid of mu1 and the system curve 2 corresponds to viscosity of mu2. While handling a liquid with viscosity of mu1, both centrifugal pump and twin screw pump have the same capacity of Q1, delivering at pressure P1, corresponding to operating point 1. When the viscosity of the fluid increases to mu2, the shape of the performance curve of the twin screw pump changes and the system curve 2 intersects new operating point 3 at which it delivers a capacity of Q3. For the centrifugal pump with the same liquid viscosity of mu2, the shape of the performance curve also changes and the system curve 2 intersects at new operating point 2 at which it delivers flow of Q2. Thus it is seen that at higher viscosity, twin screw pump delivers higher capacity, whereas centrifugal pump delivers lower capacity. This figure illustrates the efficiency change as the viscosity changes. As the viscosity increases, the efficiency of centrifugal pump decreases, whereas that of the screw pump increases. How do you explain this? Displaced volume Vd of the screw pump is a theoretical volume displaced per revolution of the rotor and is dependent on the physical characteristics of the pump design. Theoretical flow rate Qth of a screw pump is expressed by Qth equal to Vd times N. The actual flow rate Qactual of a screw pump is expressed by Qth equal to Qactual plus S. Where S is the slip, N is the speed of rotation. Before we move on, I would like to make a call to my dear viewers. Your SPEC e-learn channel is a one-stop learning and skill development channel for your career. So do not forget to subscribe. Please press the subscribe button right now. The figure below shows a typical twin screw pump performance curve. This curve is valid for a certain speed only. When the speed is increased, the curve for Qth or Qactual, respectively, just moves to the right. The difference between Qth and Qactual at a given differential pressure is a backflow delta Q, which is influenced by the product's viscosity. A higher viscosity will lead to a more vertical gradient of Qactual. The efficiency of the pump is the product of volumetric efficiency, mechanical efficiency, and hydraulic efficiencies, as given below. To calculate the efficiency for a screw pump, the most important factor is the volumetric efficiency. The two other efficiencies are high enough and close to 1. Thus, it is obvious the effect of viscosity on volumetric efficiency is what gives the screw pump higher efficiency as the viscosity increases. Twin screw pumps application range. Shown in this figure is a twin screw pump, which is used in several high viscosity liquid transport applications, particularly with changing viscosity parameters, specially designed for handling hazardous and flammable liquids. Twin screw pumps are available in capacities up to 4,500 cubic meter per hour and pressures up to 100 bars for liquids with viscosities ranging from 1 to 100,000 centistrokes. They especially have an excellent track record for viscous media. Example, heavy crude oil, fuel oil, etc., which is quite often heated for viscosity reduction. Another important factor is their insensitivity against changing operating parameters and variation of the viscosity of the media being pumped. Twin screw pumps have a wide field of application in oil tank farms and terminals. Twin screw pump has the capability to transport viscous oils up to 700 km. Twin screw pumps are also used in polymer industry for recirculation of liquid polymers in the reactor loop as well as for transferring polymers finished products from one vessel to other and from vessel to tank forms. Twin screw pumps versus centrifugal pumps life cycle cost. Two most important parameters used for evaluating the pump alternatives are combined capital and maintenance cost and efficiency. Rotary screw pumps stand out on these parameters. Although the initial cost is higher, the combined capital cost and maintenance cost of rotary screw pump is much lower than that of a centrifugal pump over the life of the pumps. That is, the cost of ownership in the case of screw pump is cheaper as compared to centrifugal pump. The efficiency of the screw pump is higher than that of the centrifugal pumps. That means the operating or energy cost is lower compared to centrifugal pumps. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.